In this lesson, we will learn how to add, subtract, multiply, and divide fractions. Let's begin with adding and subtracting. The steps here are as follows. First, create equivalent fractions with the same denominator. Then add or subtract the numerators and keep the denominator the same. So, for example, to add 1/3 and 1/6, we need to first rewrite the fractions so that they have a common denominator. To do this, we should determine the smallest number that 3 and 6 will divide into. In this case, the smallest number is 6. So we will rewrite the fractions so that they both have a denominator of 6. So let's take 1/3 here and multiply top and bottom by 2 to get the equivalent fraction 2/6. The other fraction, 1/6, already has a denominator of 6, so it can be left as is and brought down here. Now that both fractions have the same denominator, we can add the numerators to get 3, and we will keep the denominator of 6. At this point, we can simplify the fraction 3/6 by dividing top and bottom by 3 to get 1/2. So 1/3 plus 1/6 is equal to 1/2. Okay, let's try another one. To subtract these two fractions, we must first rewrite them so that they have a common denominator. So what is the smallest number that 4 and 10 will both divide into? In this case, the smallest number is 20. So we will rewrite the fractions so that they both have a denominator of 20. To do this, we'll take 3/4 and multiply top and bottom by 5 to get the equivalent fraction 15/20. Then we'll take 7/10 and multiply top and bottom by 2 to get its equivalent fraction 14/20. Now that both fractions have the same denominator, we can subtract the numerators. So 15 minus 14 equals 1, so this is the numerator, and we will keep the denominator of 20 the same. So 3/4 minus 7/10 is equal to 1/20. Okay, now let's look at multiplying fractions. The rule here is very straightforward. Multiply the numerators and multiply the denominators. So to find the product here, we multiply the numerators 2 and 5 to get 10, and we multiply the denominators 3 and 7 to get 21. What about this example? How do we handle mixed numbers? Well, the rule here is to first convert any mixed numbers to entire fractions before multiplying. So first, we will rewrite 3 and 1/2 as 7/2, and then we will rewrite 1 3/4 as 7/4. At this point, we can multiply the numerators, 7 and 7, to get 49, and we can multiply the denominators, 2 and 4, to get 8. So 3 and 1/2 times 1 3/4 is equal to 49/8. If we wish, we can convert 49/8 into the mixed number 6 and 1/8. To find this next product, notice that we can first rewrite 7 as the fraction 7/1. And then when we multiply the numerators, we get 35, and when we multiply the denominators, we get 6. So 5/6 times 7 is equal to 35/6, and if we want, we can convert this to the mixed number 5 and 5/6. Finally, to multiply these three fractions, the rules remain the same. When we multiply all three numerators, we get 21, and when we multiply all three denominators, we get 100. So the product here is 21/100. All right, now consider another product. If we multiply the numerators here and the denominators, we end up with some very large numbers. However, before we perform any multiplication, we should first see if we can simplify the fractions. For example, we can simplify 23/46 by dividing top and bottom by 23 to get the equivalent fraction 1/2. We can also simplify 33/44 by dividing top and bottom by 11 to get 3/4. Now that we have simplified both fractions, it's much easier to find the product. First, we multiply the numerators 1 and 3 to get 3, and then we multiply the denominators 2 and 4 to get 8. So our product is 3/8. Okay, what about this one? Here, both of our fractions are already written in lowest terms, so we cannot simplify them any further. However, before we multiply these two fractions, we can make our work a lot easier if we cross-simplify the fractions first. Here's how cross-simplifying works. First, examine the numerator of one fraction and the denominator of the other fraction and determine whether we can divide both values by some number. In this case, we can divide both numbers by 5. When we do this, the original 10 and 25 simplify to be 2 and 5. At this point, we examine the other numerator and denominator and determine whether we can divide both of these values by some number. In this case, we can divide 9 and 27 by 9. When we do this, the 9 and 27 simplify to be 1 and 3. Now that we have completed our cross simplification, we can multiply the numerators to get 2, and we can multiply the denominators to get 15. Alright, now let's move on to dividing fractions. Here the rule for dividing fractions is to multiply by the reciprocal of the divisor. Now don't forget, the reciprocal of a fraction is the flipped over version of that fraction. So if we want to divide 1/4 by 2/3, we must first recognize that 2/3 is the divisor. It is the number we are dividing into 1/4. At this point, we can apply our rule to see that 1/4 divided by 2/3 is equal to 1/4 times the reciprocal 3/2. From here, we simply multiply. When we multiply the numerators, we get 3, and when we multiply the denominators, we get 8. So 1/4 divided by 2/3 is equal to 3/8. Okay, let's try another one. Here the divisor is 1 and 5/6. To find the reciprocal of this, we must first rewrite it as the entire fraction 11/6. At this point, we'll take our divisor and find the reciprocal of it and multiply it by 7/12. Now before we multiply, we should first cross simplify. So we can take the 12 and 6 here and divide them both by 6 to get 2 and 1. Now since we can't simplify 7 and 11, we'll leave them as they are. Now that we have finished cross simplifying, we can multiply the numerators to get 7, and we can multiply the denominators to get 22. Okay, let's try one last question. To simplify this awful looking fraction, we should recognize that the fraction here can be thought of as division. In this case, it is the same as 10/33 divided by 25/11. To perform this division, we multiply 10/33 by the reciprocal of 25/11, which is 11/25. Now before we multiply, we should cross simplify. We can take the 10 and 25 here and divide them both by 5 to get 2 and 5. And next we can take 11 and 33 and divide both of them by 11 to get 3 and 1. At this point, we multiply the numerators to get 2, and we multiply the denominators to get 15. So our awful fraction here simplifies to be 2/15. Alright, let's summarize. In this lesson, we learned how to add, subtract, multiply, and divide fractions. In this lesson, we will examine some important properties of fractions. The first property involves splitting products in the numerator and denominator. So as you can see from the rule, if we have products in the numerator and denominator, we can rewrite the fraction as the product of other fractions. This can often make our calculations much easier. For example, it would take a long time to evaluate this fraction if we had to first find the product in the numerator and then find the product in the denominator. However, when we apply the rule, we can break the fraction into the product of smaller fractions. From here, we can see that 6/6 equals 1, 15/3 equals 5, and 24/4 equals 6. From here, 1 times 5 times 6 equals 30. Also note that we can rearrange the terms in the two products so that the resulting fractions make for faster calculations. When we simplify these fractions, we get the product of 4, 3, and 1, which is 12. Now we can also apply the same property to simplify algebraic expressions. Now in the past, you may have heard people say that we can take a fraction like this one and simply cross out the 22's in the numerator and denominator to get a simplified fraction, 3y plus 5 over 8. What's really happening here is that we are applying the above rule to rewrite the fraction as the product of two fractions, And from here we can recognize that since 22 over 22 simplifies to be 1, the 22's essentially disappear, leaving us with the simplified fraction 3y plus 5 over 8. Now please note that in order to apply the rule here, we need to have products in the numerator and denominator. The rule does not apply to addition. If there are sums in the numerator and denominator, we cannot split the fraction into the sum of smaller fractions. For example, this fraction is not equal to the sum of these three fractions. Notice that the left-hand side here simplifies to be 6 over 6, or 1, and the right-hand side simplifies to be 1 plus 1 plus 1, which is 3. Now there is, however, a property that does allow us to split a certain kind of sum. It looks like this. Notice that we are splitting the numerator into two parts, but the denominator stays the same. So, for example, we can take this fraction and rewrite it as the sum of these two fractions. This property also works with subtraction, so this fraction can be rewritten as follows. Now, the important point to recognize here is that we are splitting the numerator, but we are not splitting the denominator. A common mistake is to assume that a similar rule applies to splitting the denominator. This is not the case. We cannot split sums and differences in the denominator. To illustrate this, notice that 1 over 2 plus 2 is not equal to 1/2 plus 1/2. When we evaluate the left-hand side, we get 1/4, and when we evaluate the right-hand side, we get 1. So clearly this rule does not work. So it's okay to split the numerator, but it is not okay to split the denominator. Notice that the following rule adheres to this. Here we are splitting the numerator, but the denominator remains the same. So, for example, we can rewrite this fraction as follows, and when we evaluate the left-hand side, we can see that it is equal to the right-hand side. Alright, the next property is related to multiplication. It says, if we take a fraction and multiply it by its denominator, the result is the numerator. So, for example, 3/4 times 4 is equal to 3. We can also apply this rule to help us solve equations. Here, if we multiply both sides by 7, we get 2x on the left-hand side, and we get 70 on the right-hand side. From here, we can divide both sides by 2 to see that x is equal to 35. We can also use this rule to simplify strange fractions, such as this one. Since the fractions in the numerator and denominator both have 7 as their denominator, let's see what happens when we multiply top and bottom by 7. First, 3/7 times 7 is equal to 3. And next, 5/7 times 7 is equal to 5. So our fraction simplifies to be 3/5. Alright, our last property looks like this. If some fraction, a over b, is equal to another fraction, c over d, then it must be true that a times d is equal to b times c. We can use this rule to help us solve equations where we have one fraction equal to another fraction. When we apply this rule, we see that 5 times 2x must be equal to 11 times 3. At this point, we can simplify both sides and then divide both sides by 10 to get x equals 3.3. Alright, let's summarize. In this lesson, we learned several important properties related to fractions. In this lesson, we will examine word problems involving fractions. Now, for word problems involving fractions, we need to know the role of the word of. In most cases, of signifies multiplication. So in this question, when we are told that 3/10 of the population plays golf, we should be thinking multiplication. So we can take the fact that 3/10 of 12,000 people are golfers and rewrite it as 3/10 times 12,000 is equal to the number of golfers. At this point, all we need to do is evaluate 3/10 times 12,000. So let's first rewrite 12,000 as the fraction 12,000 over 1. And from here we can cross-simplify 10 and 12,000 by dividing each number by 10 to get 1 and 1,200. Then we multiply the numerators and the denominators to get 3,600 over 1, which equals 3,600. So there are 3,600 people in Townville who golf. Okay, let's try another question. Here we are told that Vashti had $36, and she spent 1/3 of that at the movie, 5/9 on a hat, and the remainder on candy. Our task is to determine how much money she spent on candy. So to begin, let's determine how much money she spent at the movie. We are told that she spent 1/3 of her $36 at the movie, which we can rewrite as 1/3 times $36, or just 1/3 times 36/1. When we calculate this product and simplify it, we see that she spent $12 at the movie. Now let's determine how much money she spent on a hat. We are told that she spent 5/9 of her $36 on a hat, which we can rewrite as 5/9 times 36. When we calculate this product and simplify, we see that she spent $20 on a hat. So from this, we can see that she spent a total of $32 on the movie and hat. If she spent her remaining money on candy, and she had $36 to begin, she must have spent $4 on candy. Okay, let's try one last question. Here we are told that 2/5 of the students at J. Smith Elementary are boys. There are 28 boys altogether, and we want to determine how many children attend the school. Well, from this question, we can see that 2/5 of the entire student population equals the number of boys. So what is the entire population? Well, we aren't given this information. In fact, our goal here is to determine the entire population. So let's let T equal the entire population of students at the school. Now, the left-hand side of our equation here says 2/5 of the students. So we can now rewrite this as 2/5 times T, since T represents the school population. This, we are told, is equal to the number of boys, which is 28. At this point, we have an equation we can solve for T. To eliminate the fraction 2/5 in front of the T, we can use the fact that the product of a fraction and its reciprocal equals 1. So if we multiply both sides of our equation by 5/2, the reciprocal of 2/5, something nice happens. On the left-hand side, when we multiply 5/2 by 2/5, we get 1, and 1t is the same as t. On the right-hand side, we can first rewrite 28 as 28/1, and then when we multiply and simplify this, we get 70. So if t equals 70, that means 70 students attend J. Smith Elementary. Okay, let's summarize. In this lesson, we learned that in most word problems, the word of signifies multiplication.